Hi everyone, welcome to another NLP General Club video. Today we're looking at a paper called Politeness Transfer, a tag and generate approach by a bunch of authors from Carnegie Mellon University. This paper proposes a new task which is about politeness transfer. So given that you have an input sentence that is either non-polite, containing non-polite words, or neutral, convert the sentence to make it more polite. And this task is similar to various tasks within the domain of text style transfer, such as converting gender from male to female or vice versa, political transfer, or converting, let's say, user reviews from negative to positive. And the contributions of the authors of this paper are they create a new dataset of 1.4 million examples of either polite or impolite sentences. And they also propose a new pipeline which can address this task without relying on any parallel sentence pairs, but by taking a two-step approach of tagging and generating, which I'm going to go through in a second. They also do automatic evaluation of this politeness task, as well as on some other common style transfer benchmarks, where it seems that their approach performs quite well in terms of content preservation, while also achieving good style transfer properties. And they also do a human evaluation, which confirms their automatic results. So let's go into the details of the model that they propose, which is depicted in this figure here. So the task, again, given that you have a non-polite, or I would call it more neutral sentence in this case, like send me the data, it's more like a direct sentence. The goal is to generate a more polite sentence like, could you please send me the data? And so the way this is done, as I said, it's a two-step approach done by two separate models, which are both sequence-to-sequence models. The first model is taking this sentence, it's a tagger model, by the way, called a tagger model, and either inserts a bunch of tags in this sentence, like here in the beginning, let's say you insert a tag, or it might also replace certain words that are non-polite or in a different style with tag tokens. And so this is done like so, and then you have a second sequence-to-sequence model, which is the generator, which takes this tag sequence, which is kind of neutral in a way, and kind of represents the main meaning of the sentence without any particular stylistic leaning. And then you generate the sentence in the target style by replacing the tag tokens with one or more words which make the style correct. So could you please send me the data? And this also works with other style transfer tasks, like transferring from negative to positive in the example below here. So from input, their chips are okay, but their salsa is really bland, to their chips are great, but their salsa is really delicious. And how does this work in slightly more detail? So basically to train this tagger model, you use a lot of sentences in the styles that you're interested in, and basically you mask them to make them neutral here. So in this case, this could involve taking this send me the data, and then which might exist in some data set, and then masking could you please, which is a polite phrase with tag. And the same for the other one. The way you identify these stylistic phrases is you take your large amount of sentences, polite and impolite sentences, and then you count you look for engrams which are not common for the two data sets, right? And they're like also not very frequent, or they might be frequent, but basically you count and you try to find like what is the mismatch in terms of engrams from those two large datasets of sentences. And the way you actually find those polite and impolite sentences is they also have some classifiers, I believe, to do this. So this is how you train this tagger model, and actually there's two types of tagging operations that they consider. You have the add tagger model, which is adding tags. Basically, this is the case when you kind of have a neutral input here, or you have a sentence which is not, maybe it's tough to classify it as either polite or impolite, and you insert the tags. And you also have the replace tagger, which replaces specific words with tag tokens, which needs to be then converted into the correct style. And so in this case, the style transfer problem is more clear because you have clear words which need to be replaced. So this gives you like an overview of this, how this approach works. Yeah, maybe I should say for the generator, you basically again you take this, given that you have this tag sentences, you train a sequence model to predict these this complete sentence which is in the correct style. And in this way, this decoupling of this process allows the authors to use this approach without any parallel data of example sentences in non-polite and polite style. So let's go through some results. As I said, they test this model on this politeness transfer task, as well as on gender transfer, political transfer, and sentiment transfer on user reviews. And for evaluation, in all of these experiments here in these tables, this is for the automatic evaluation. They first report some accuracy of a classifier trained to distinguish between each of those styles. So higher is better here. You also have, for all of those, higher is better actually. You also have some blue metrics and Meteor and Rouge, which are all for meaning preservation. So you want to have a good trade-off between leaning towards the target style of polite sentences while still preserving the original meaning of the input sentence, which is impolite or neutral. And what they find is that comparing against a couple of systems, you have this cross-align autoencoder, which is a previous approach to non-parallel text-style transfer. You have this one is a back translation approach, and you have this DRG's another paper which is taking I think it's a similar pipeline for doing this kind of like a text editing approach rather than completely regenerating the sentences, but just modifying words. And it seems that their approach here in the last row here is achieving comparable style across those benchmarks, while resulting in better meaning preservation, which makes sense because basically they are just modifying individual words or inserting some words, so there's this less risk at affecting the meaning of the original sentence. But as you may be aware, when it comes to automatic evaluation, it's a very problematic to do this for these tasks, which have you have a very large overlap typically between inputs and outputs. And also style is very difficult. I mean, okay, basically if you just generate please, 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 or something like this, probably your output sentence will be classified as being polite, but obviously that's not the point. The authors also do a human evaluation on these tasks, comparing this DRG approach to their approach in terms of three kind of attributes. Content preservation, so asking the users to rate from 1 to 5 to what extent is the content preserved. Attribute, which is basically the style, is the target style matching the expected style from 1 to 5. And then finally, they also check whether the grammaticality is, what is the quality of the grammar used in the output sentences. And it seems that consistently on all of those politeness as well as other style transfer tasks, gender, political, and Yelp, it seems that their approach proposed in this paper outperforms this DRG approach. So here we also have some examples to see how how this works. So let's say you have an input, what happened to my personal station? And then their model generates, could you please let me know what happened to my personal station? Which is obviously more polite. And let's see, for example, the other one, please check on Metro Media Energy. It was converted to, please check on Metro Media Energy, thanks. So it's doing this kind of insertions here. So I think this was all that I wanted to cover for this paper. It's a very interesting approach to style transfer that doesn't rely on parallel corpora, and in particular seems to be effective when you have basically very low change in style or in meaning from the input to the output. So here you're able to target this because basically you can make this work by inserting some style specific words or by doing some word replacements. One limitation that I can think of this approach is that if you have a huge difference in vocabulary from the input to the output styles, so if the style transfer task requires more drastic rewriting, you may have some challenges using this approach, because if you go back to this example, this generator, if as input you're having a huge amount of tags, it would have to basically invent and fill in a lot of, maybe too many gaps, and at one point it might get too difficult for the generator to figure out, okay, what should I generate here, like especially if like some of the meaning is lost due to the tagging operation here. And another potential limitation is that this is not an end-to-end approach, so you need to train these two models separately. So hopefully they are going to be working together well, but it would be great if it's possible to somehow fine-tune them still in an end-to-end fashion, such that you can guarantee that they're working well together. But obviously it's very difficult to do this without having a parallel dataset. So that is all that I wanted to cover, an overall interesting approach, and I encourage you to check out the paper and read it, and there you will find some more interesting, cool examples. So that is all from me. Thanks for watching, and please subscribe and like, and I'll talk to you soon for the next NLP video.